Hi, this video will give you an introduction to the alkene homologous series of hydrocarbons. It covers the structure of the first four alkene molecules and introduces the general formula to find the molecular formula for these alkene molecules. The alkenes are a homologous series of hydrocarbons, that is, molecules made up of only the elements carbon and hydrogen. Now recall that an homologous series is a family of compounds with similar chemical properties, and that the physical properties of the molecules in the homologous series show a gradual change as we move from one member of the series to the next. And finally, all members of a homologous series share the same general formula. The alkenes are unsaturated molecules. This means that they contain a carbon-carbon double covalent bond. For example, the first alkene molecule is ethene. A ball and stick model of an ethene molecule is shown below. Now recall that each carbon atom always makes 4 covalent bonds, and each hydrogen atom always makes 1 covalent bond. Since there is a double covalent bond between the carbon atoms, this means that each carbon atom in an ethene molecule can make 2 more bonds to hydrogen atoms. This means that the molecular formula of an ethene molecule will be C2H4. There are double the number of hydrogen atoms as carbon atoms in this molecule. The next member of the alkene homologous series is propane. Now the molecular formula for propane is C3H6, and it is obtained by simply adding a CH2 group to an ethene molecule. A ball and stick model of a propane molecule is shown. Now like ethene, it contains 1 carbon-carbon double bond and so is unsaturated. Now you may see a number of different ways to draw these molecules. For example, the displayed formula for a molecule shows all the bonds present, and all the atoms present in the molecule are also shown. The structural formula is similar to the displayed formula, but not all the bonds are shown, although all the atoms present within the molecule are clearly indicated. So when we come to name many organic molecules, such as the alkanes and the alkenes, the first part of the name will tell you the number of carbon atoms present in the molecule. For example, the prefix meth indicates a molecule with 1 atom of carbon, while the prefix eth indicates a molecule with 2 atoms of carbon, and the prefix prop indicates a molecule with 3 atoms of carbon. The prefixes which are used to name molecules with up to 10 carbon atoms are shown, and it might be a good idea to try and learn these prefixes. Now the second part of the name of a molecule indicates the family or homologous series that the molecule belongs to. So for example, all the alkanes which we previously met end in the letters ANE, while all unsaturated alkenes will end in the 3 letters ENE. Now let's have a look at how we would name alkene molecules. Now all the alkene molecules, as we have seen, contain a carbon-carbon double bond. So this means that the first alkene molecule must contain at least 2 atoms of carbon. So the first alkene molecule is ethene, and there will be no such molecule as methane, as a molecule of methane would contain only 1 atom of carbon, and obviously the minimum number needed for a double bond is 2 carbon atoms. In all the alkene molecules we have seen so far, the number of hydrogen atoms has always been twice the number of carbon atoms. Now this leads to a general formula for all alkene molecules of CnH2n, where n is simply a whole number. Now the next alkene molecule is butene. It should have 4 carbon atoms and 8 hydrogen atoms if it fits the pattern above. Now if you count the number of atoms present in butene, you will see that this is indeed the case, and so a butene molecule will have a molecular formula of C4H8. Finally, the next alkene in the alkene homologous series is pentene. It should have the molecular formula C5H10, and by counting the number of atoms in the ball and stick model shown, we can indeed say that this is the case. So we can easily use the general formula to find the molecular formula for any alkene molecule. The two ball and stick models show images of the molecules butene. Both the models have the same molecular formula, that is C4H8, but if you look carefully, you will see that the molecules are slightly different from each other. In the left-hand model, the carbon-carbon double bond is between carbon atoms 1 and 2, and in the right-hand model, the carbon-carbon double bond is between carbon atoms number 2 and 3. The left-hand model is called but-1-ene, where the 1 indicates the position of the carbon-carbon double bond in the molecule, and the right-hand model is called but-2-ene, with the 2 indicating that the carbon-carbon double bond is between carbon atoms number 2 and 3. If you're asked to draw alkene molecules, you should be aware that it does not matter where you put the carbon-carbon double bond in the molecule, as shown above, as both these molecules are molecules of butene. However, you should always check that each carbon atom always makes 4 covalent bonds. Molecules like this, which have the same molecular formula, but the atoms are arranged slightly differently, are called isomers. As molecules get larger, there are more and more possible isomers that you can draw for each molecule. Hi, thanks for watching, and hopefully you found this video useful. If you need more help or information, then why not simply visit the website that accompanies these videos. Click the links in the description below if you need more help or information.